So from last time, I gave you this diagram, and I asked you to find the coordinates of each of these. And I said to you, it's not really worth trying to draw this yourself. Just take a screenshot or do something of the sort, and then you'll be able to refer to it later. So the answers are as follows. So A is 3, 2. So there's 3, 2, because remember, you always put the X first. 1, 2, 3. How did I know that each notch was 3 units? Well, I can see that this is 5 over here, and there's 1, 2, 3, 4, 5 notches up to 5. Therefore, each of them have to be 1. So 1, 2, 3 across makes 3. 1, 2 up means that that coordinate is 3, 2. You can either write it as 3, 2, or you can write it as 3, semicolon 2. It doesn't matter, both would be correct. All right. B is 5, 5, because you go all the way to 5 across and all the way to 5 up. C is 7, 8. So you go 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Remember, you always put your X first. D is -6 and 4. So there's D. So you go 1, 2, 3, 4, 5, 6. So it's in the negative direction, that direction. So it's -6 up, which is positive. So it's +4. All right. -3, 7. -4, -6. -8, -8. 9, -9. And 6, -5. So Jean, we are marking the ordered pairs and Cartesian plane work, and then moving on to scale diagrams. All right. Any questions on these? Anyone get different answers and they don't know why or how or anything like that? So we are going to be moving on to scale diagrams. All right. Now, the idea of scale diagrams is that sometimes you need to draw things. And the problem is that not everything can fit on a piece of paper in real life. So if you think about an airplane, if you were to draw it according to its actual size, is quite significantly bigger than, for example, a normal A4 page. Maybe an A3 page even. So how are we actually able to draw exactly what an airplane should look like, all of its specifications and parts, but on a reasonable size page? Well, that's where your scale comes in. So you'll find that there are many times that scale diagrams actually will be used in your life. Majority is when there's building. So if you're building a house or building a plane or building anything, you're going to need to know relative sizes so you know what kind of materials and how much material you're going to need. So generally, you will find that somewhere towards the bottom of a diagram, you will have a scale. Often it's actually in the bottom right-hand corner, but it will be somewhere. So this scale here says that that particular distance is equivalent to 5 meters in real life. So if you're struggling to see the picture, I'm going to enlarge it a little bit for you. So there's your scale. So this says that if you were to measure this distance here, so that distance, there's 1, 2, 3, 4, 5, which means this would be 1 meter. Now, that's not an actual meter. I mean, everyone knows what a meter is roughly. Most adults are 1.8 meters tall. a story of a building is just over 3 meters. So 1 meter cannot be that length. But what they've done is they've changed the scale of this picture so that if you are to measure that distance, which is very roughly, for example, that distance there, then that will be about a meter in real life. And they do that so that they can actually get this whole diagram onto a reasonable size sheet. Now, this diagram is very nice because it shows you metric units and imperial units. So if you haven't got into your metric and imperial units yet in your course, don't worry. Essentially, America is one of the only countries in the world that still use imperial units, being feet, miles, gallons, stuff like that, inches. So you'll see here that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 blocks. And that distance from the beginning there up to here is 15 feet in real life, which means each little block here is going to represent 1 foot. And 1 foot, in case you weren't aware, is essentially a ruler, a 30-centimeter ruler. So that's where the term a foot-long sandwich comes from, because it's meant to be 30 centimeters long. All right, so you can do any of these measurements converted to real life, which is interesting. But I'm sure for many of you, you're thinking, oh, I may not have built anything in my life. I haven't built a house, you're still kids. You very possibly may not have built a model aeroplane or anything really. So where could you have seen scale diagrams already in your life? So type on the chat, tell me where you think you could have seen a scale diagram in your life already. Your parents probably use it very often. A map, Oliver. What kind of map? Exactly, Laura. So maps of places, city map, the street map, anything of the sort. And you can then therefore either use a map book and you would see it. Thank you, Jana. Building plans, exactly right. Or Google Maps, an app that many people have on their phones already. So if we go to Google Maps, I'm going to put it up for you. I'm going to reshare. Google Maps. All right. So Google Maps always has a scale. And you may not have noticed this because most people only ever look up here on Google Maps. If we have a look at the bottom corner down here, that tiny little bit over there, it says 200 meters and a little brackety thing over there. That is actually your scale. So it's saying if you measure that distance on this map, it is equivalent to 200 meters. Now, if I zoom in, it is now double that distance to say 200 meters, which means equivalently that distance is now only 100 meters. If I zoom in again, it's now halved it again to 100 meters for the whole thing. I zoom in again, it's now 50 meters. But equivalently, I can keep zooming in. I think they go up to 5 meters, yeah? So 5 meters over here. and you can scroll and do whatever you need to get to where you want to, which is very interesting. But as I keep zooming out, it makes sense that the exact same distance that you're measuring on your screen now represents a different distance in real life. And each time I zoom out, this distance would be more and more. And that's why this little measurement over here keeps increasing. 200 meters. It's now 200 meters for half of that. 500 meters for 2.5 times. A kilometer or 1,000 meters. 2 kilometers. 5 kilometers. 10 kilometers. And you keep going, and you keep going, and you keep going. 500 kilometers. 1,000 kilometers. So that distance there is 1,000 kilometers. So the smallest that Google Maps goes is actually 2,000 kilometers. And you can then just scroll through the globe. All right. So that is the point, the main point of this. All right. So you see that scale diagrams, they're all about ratios. So if you have something that says, for example, 5 centimeters is 50 meters in real life, well, what would that make 10 centimeters on the diagram equal to in real life? Well, 5 to 10 means you're doubling it. So therefore, you double 50 meters, you get 100 meters. 5 centimeters to 50 meters, now you're measuring 50 centimeters. 10 times this means it's going to be 10 times that distance in real life, being 500 meters. So Laura says, why will a bigger number in this case be smaller? So in other words, they were keeping their measurement the same as I zoomed out. So as you zoom out, you're going to cover more of real life in this set distance, and that's why the value kept on getting bigger and bigger for the set distance. Or you can keep what distance it represents the same and then just count more or less as a distance. Those are two ways. They've just chosen to keep it as consistent a distance as possible. All right. So how are you actually going to have to work with this in a test or an exam? Well, there are 3 ways. Either you're going to be given a measurement on a diagram and a measurement in real life and be asked to calculate the scale. And the scale will be given in terms of a ratio. And remember, a ratio is always a number with a semicolon and then another number. So for example, the radius of an arena on a scale diagram is given as 8 centimeters, but the radius in real life is 120 meters. What is the scale? So you need to take it as a ratio of scale diagram to real life. And you will always do the scale diagram first because that will always represent the smaller value. So 8 centimeters to 120 meters. But we've got a huge problem right now. Our problem is that this is centimeters and this is meters. That's a problem because they're unlike units. So we need to make sure that these units become the same. And we can convert them either way, all to meters or all to centimeters. That's totally up to you. Our aim, though, is to try and get a 1 over there and then another value over there. If it's going to create a fraction, then this might not be a 1, but we'll have a look at that a bit later. So I'm going to change the 120 meters into centimeters, and I know that 1 meter is 100 centimeters, which means that if I multiply the 120 meters by 100, I'll get 12,000 centimeters. Now they are the same unit, which means now I can try and simplify these values. And to simplify it, I divide it by 8 so that I can get a 1 on my left-hand side. And 12,000 divided by 8 gives me 1,500. So therefore, my ratio, or my scale, is 1 to 1,500. Another way that we could look at this, or another way it could be examined, is that you could be given the measurements on a diagram or in real life, and the scale, and then be asked to calculate the other missing measurement. So if you're given the diagram measurement, you have to calculate the real life measurement. If you're given the real life measurement, you have to calculate the scale diagram, the diagram measurement. So I'm going to use the exact same example in this and the next example, just to show you all the different kinds, but all with the same example. So the radius of the arena is 8 centimeters, just as we saw before, and the scale is 1 to 1,500. What will the radius in real life be? And I'm specifying we have to answer in meters. So this 1 to 1,500 means that whatever measurement unit you have will be the equivalent of 1,500 of those same measurements in real life. So it could be centimeters, it could be meters, it could be kilometers, it could be millimeters. It doesn't matter as long as it's the same units. So I've chosen centimeters here. So 1 centimeter is 1,500 centimeters. I was told that my scale diagram is 8 centimeters, so I have to times this by 8, and therefore I have to times that by 8. So what will 8 centimeters here be? Well, it's my 1,500 times 8, and that gives me 12,000 centimeters. So if I see 8 centimeters on my diagram, that's 12,000 centimeters in real life. But remember I said answer in meters. So therefore 12,000 centimeters divided by 100 will give me 120 meters. Remember 100 centimeters in a meter. And remember from our previous question, we were told that the radius was indeed 120 meters. And then our last one, we look at the other case. Still, the radius of the arena in real life is 120 meters. My scale is 1 to 1,500. What is the radius on the diagram? Give your answer in centimeters. So I've now chosen to start it in meters. I could have started it in centimeters. It really doesn't matter. So I've taken meters here to start. I've converted it to centimeters because I've chosen to get it into centimeters at the beginning, not at the end. It doesn't matter for you. There are many ways to calculate this. I now know that 120 meters is 12,000 centimeters. So I say, what do I need to divide 150,000 by to get 12,000? Well, I have to divide it by 12.5. And what I do to this side of my ratio, I have to do to this side of my ratio. So therefore, 100 divided by 12.5 gives me 8 centimeters. And remember, whatever on the left is going to be my scale diagram. And therefore, my scale diagram is 8 centimeters. So this section is very late in your course. This is from week 28, I believe it is. So if you haven't come to it, don't worry. If you aren't too sure, don't worry, you will be coming to this. But as I've always said to you, the purpose of these lessons is to give you some teaching, irrespective of where you are in the course.